Hi, I'm Miss Hall, and this is lesson 15, factoring with sum, difference of cubes, quadratic form, and trinomials with a greater than 1. So in lesson 14, one of the special factoring patterns was factoring the difference of two squares. There's also factoring patterns for the sum or difference of two cubes. And this is probably new to you in Algebra 2. So we'll start with the sum of two cubes. If you have a binomial with addition in the middle and each term is a perfect cube, then you can factor out, you can go from the binomial to the product of a binomial and a trinomial. Same as if you have two perfect cubes that are being subtracted, so you have a binomial of two perfect cubes. There is a factoring pattern here where it is really the product of a binomial times a trinomial. So to get into the mind frame of perfect cubes, I put the first 5 cubes, so like 1 cubed, right? That means 1 times 1 times 1 is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Let's get right to an example. So example 2, factoring the sum and difference of two cubes. Factor x cubed minus 125. Well, 125 is a perfect cube, right? We see it over here. This is really 5 to the 3rd power. And x cubed can be written as x to the 3rd power. So our a value here is x, our b value is 5, and this is a difference of two cubes, so we're using the second factoring pattern. Therefore, factored out, this is really a minus b, which is x minus 5, times a squared, so that's x squared, plus 5 times x, which is 5x, plus 5 squared, 25. Part B, we're going to factor 16s to the 5th plus 54s squared completely. 16 is not a perfect cube, so that gives me a clue that I need to do something first. And what I'm going to do is I'm going to look for a GCF of both terms, and I see that I could take out a GCF of 2 and s squared. When I factor out that 2s squared, I have 8s to the 3rd. That's looking good. 8 is a perfect cube. Plus half of 54 is 27. Great. Now I have the sum of two cubes, and I can't forget that first factor. So this needs to come with the expression as I factor it. It might help me to rewrite this binomial as 2s cubed plus 3 cubed. I want to bring 2s squared along with it so I don't lose that term. And so my a value here is 2s, my b value is 3. And I still have that first factor, so I have 2s squared times, and now I'm using the first factoring pattern, so I have a plus b, which is 2s plus 3 times a squared is 4s squared minus ab, so that's minus 6s, plus b squared plus b is 3, 3 squared is 9. Now I have completely factored that binomial. Example 4, factoring polynomials in quadratic form. Factor 16x to the 4th minus 81. So at first it doesn't look like any of the factoring patterns that we've seen, but hidden in that binomial is a difference of squares. I can rewrite this binomial as 9 squared and 4x squared. And so now you see there's really the difference of 2 squares. When you have the difference of 2 squares, plus, minus, you take the square root of the first term, which I've already done. It's 4x squared, and that is the first term in each factor. And then you add or subtract the square root of the second term. The square root of 81 is 9, so plus or minus 9. Now I just look to make sure I'm done factoring. There's nothing further I can do, but there is. I now have a difference of squares again. I've got to bring over that first factor, 4x squared plus 9 must stay with my solution. And now, like I was saying, the difference of 2 squares, 1 plus, 1 minus, we take the square root of the first term, 2x, and then the square root of the second, that 9 is 3. Now, there is nothing more I can factor, so I've completely factored part A. Now B, I'm going to completely factor this trinomial. Let me see. Well, there's a GCF, so I can take out 3p squared. What I'm left with is p to the 6th plus 5p cubed plus 6. Now, in this trinomial of p squared plus 5p cubed plus 6, that's in quadratic form. Meaning, let's see, how am I going to represent this? I'm going to bring down the 3p squared. I can show this as p cubed squared plus 5p cubed, so that's to the first, plus 6. So if those orange p cubes were just x's and we had x squared plus 5x plus 6, you could factor it. And what we're going to do is we're going to treat that p cubed, that's now the x. So I still have 3p squared on the outside, and I'm going to factor this trinomial. My first term will be p cubed, that is my new x value. Now I'm looking for two numbers that multiply to 6 and add to 5, and that's positive 3 and positive 2. Okay, so that's what we mean by quadratic form, that the expression can be rewritten as something squared plus a coefficient plus that thing. Making sure there's nothing more I can factor. There isn't, so I'm done. This is completely factored. A is the difference of squares. So I'll rewrite this. This is really, can be written as 25x to the 4th squared minus 16 squared. And so for the difference of two squares, I add or subtract. The square root of the first term is 25x to the 4th. Square root of 256 is 16. Now I have a difference of squares again. Not the first factor, so I'm just bringing it down. Difference of squares, take plus and minus. Square root of the first term is 5x squared. Square root of 16 is 4. Checking again. Nothing more I can factor. A is done. B. Looks like I can take out 2x to the 5th. 2x to the 5th is my GCF, my greatest common factor. I am left with x to the 8th plus 5x to the 4th plus 4. 25, not 25, 2x to the 5th. Now this is in quadratic form. If I wanted to rewrite, oops, that would be to the 1st. This would be x to the 4th squared plus x to the 4th to the 1st. So there's the quadratic form, which means my factors here are going to be 2x to the 5th, x to the 4th is the first term in my binomial factors. Now I'm looking for two numbers that multiply to positive 4 and add to positive 5, plus 4 plus 1, and there's nothing more I can factor. I'm done.